At this point, I would like to take a short break from linear regression and get into the topic called cluster analysis. I'm doing this only because some of the ideas that we have learned about in general in regression are quite relevant to this technique called cluster analysis, which is a useful technique. And I thought it would be a good time for us to look at this when those concepts are fresh in our mind. And then once we finish this, we'll get right back to linear regression. Okay, so let's take a look at what is this technique called cluster analysis. Right at the outset, before we begin, I want to make clear to you that this is not a predictive analytics technique. Cluster analysis is not used to do any predictions. It's more a way of describing your data. Okay, so in that sense, it's not a predictive analytics technique. It's not a supervised learning technique. In other words, when you do cluster analysis, it's not learning from the historical data about what is good, what is bad, and how to adjust the model so that it makes good predictions. It's not any of that. Okay, so shortly you will understand what cluster analysis is. But this is a course in predictive analytics, but this is the only technique that I'll be teaching you, which is not a predictive analytics technique. Okay, so let's take a very intuitive understanding of cluster analysis. So let's say I show you this picture and ask you to think about what's going on here, right? So if I ask you a question of what do you see in this picture? Now, some people may say, well, this is a picture that consists of a bunch of circles or ovals and a bunch of diamonds. Some people would see it like that, right? So they would say, I see some circles and ovals and I see some diamonds. That's how they may classify it. Some other people may say, well, I see some smooth figures, which are the circles or ovals, and I see some, rough figures, which have hard edges like the diamond. Some other people may come and say, well, I see some figures which are all closed geometric shapes. Some of them are small, some of them are big. Okay, no matter what we are trying to do here is we are seeing a lot of objects, and immediately what our brain wants to do is to somehow simplify what we are seeing and capture the essence of it in a simpler statement, right? So we've got many objects here, maybe about 15 objects. We don't want to deal with the differences between all these 15 objects. All we want to do is to reduce them to just two concepts, right? We say there is one concept which is all the diamonds, and there's another concept which is all the circles or ovals. That's it. There are only two concepts. Okay, so this is sort of what our brain does all the time, and cluster analysis is essentially this. Okay, the purpose is this. So for example, suppose you've got a company and the company has tens of thousands of customers. Okay, and of course customers have their own attributes, how much they buy, how much they consume, in what region of the country they live, what is their income, etc., etc. There are many attributes of the customers, right? Now, in order for the company to, let's say, promote its product properly to its customers, it can take several approaches, right? Obviously, one approach the company could take is to simply advertise the product to everybody, right? In other words, have one advertisement campaign directed at its whole consumer population. Okay, in this case, what is happening is that this is a one size fits all kind of an approach, right? You're adopting the same advertising strategy or promotion strategy for all your customers, although you know fully well that there are differences among customers. Some things appeal to some customers, some things don't appeal to some customers. Well, what do? The other approach is for you to try and craft a separate promotional message for each of your customers, which is impossible, right? You have hundreds of thousands or even millions of customers. How are you going to sit down and craft a separate promotional message for every single customer? That's not possible, right? On the other hand, the one size fits all approach is also not great. Okay, so in cluster analysis, what we are trying to do is to say, okay, let's not go to either of these extremes. Let's try and find from our customer data some way by which we can take our millions of customers and put them into some small number of buckets. Okay, maybe 10, maybe 15, right? In other words, what you're saying is you're taking all your customers and dividing them into some small number of groups such that all the customers within a group are quite similar. They're not identical, but there's a lot of similarity between all the customers in one group. And the customers in one group differ quite significantly from customers in other groups. Okay? In other words, what we are trying to say is I want to take all the customers and break them up into individual clusters, a small number of clusters, so that I can address each cluster separately. That is, instead of having the complexity of dealing with millions of customers, I have now reduced the problem to one of dealing with, let's say, 15 groups of customers. And within each group, you have customers who are quite similar to each other. That's the task of cluster analysis. Okay, so obviously it has applications in customers. Also, if you've got, let's say, Amazon.com, who are selling tens of thousands or probably even hundreds of thousands of products, okay, they may have a need to cluster their products for various management purposes. Of course, a university has students, and you may want to cluster your students into groups for certain purposes, right? Or let's say you've got a, a school, you've got a bunch of kids in school, and you need to assign, let's say, a basketball coach to the kids. Now, obviously, you have quite a lot of variability among the kids in terms of their strength, in terms of their weight, in terms of their height and abilities, and so on. You don't want to have uh, provide the same coaching to all the kids. Okay. At the same time, you cannot be coaching every kid individually. So you say, okay, I'm going to take up the class, split up the class into 2 or 3 groups of similar capabilities and abilities, and then have a coach for each of those 3 groups. Rather than having 50 different coaches for all the students, you now have 3 coaches for a fairly homogeneous set of students. Okay, and so on. There are many scenarios where you can think about cluster analysis as applicable. Sometimes people talk of cluster analysis as a data reduction technique of some kind, right? That is, you're taking your large data set and reducing its complexity significantly by trying to make it into homogeneous groups, a small number of homogeneous groups. Okay, so let's say you've got 3 clusters, cluster 1, cluster 2, cluster 3. Okay, what we want to say is that cases within a cluster are closer to each other or very similar to each other, and cases in different clusters are quite different from each other. Okay, so instead of having, let's say there are a total number of 30 points here, instead of dealing with 30 different cases, you're dealing with only 3 clusters, right? So within a cluster, you can talk about the average value in the cluster as representative of the cluster itself, right? So what you're trying to do is to reduce the complexity by saying, instead of dealing with 10,000 customers, I'm going to deal with 5 clusters, right? But of course, you also have the problem of retaining to some extent the diversity that exists, right? That is why we are saying a one size fits all doesn't work, right? Because there are differences between people. You can't afford to ignore that and just have a single message going out to all customers, right? So you want to reflect to some extent the diversity that exists. You want to say, okay, this group is different, has different needs than that group. I don't want to lose sight of that, right? So that's the thing. You want to reduce complexity. You also want to retain diversity, because the easiest way to reduce complexity would be a one size fits all approach, right? So I've got a million customers, so what? I'm going to treat them all as one homogeneous group. So I reduce the complexity, but then I lost the diversity, right? I'm not able to reflect the differences that exist between them. To go to the other extreme, you may say, well, in that case, I'm going to treat every single case as special. okay, which is also not possible because it's just too many things to do. You've got a million customers. You can't be dealing with each one of them separately, right? So you cannot go to either side. You have to find a balance, and that's what cluster analysis is all about. Okay, so complexity is measured by number of objects, right? And it's very easy to see how do you reduce complexity. Well, instead of dealing with 10,000 customers, deal with 5 clusters. That's the reduction in complexity. And how do you measure diversity? Okay, so diversity is measured in terms of how much variability there exists within that group that you're talking about. Okay, once again, if you recall our discussion with regression, variability is measured by sum of squared deviations from the mean, right? So you've got all the values, you calculate the mean, and then you see by how much each value differs from the mean, square it. Okay, so that's the variability that exists. So those are the two things we are trying to look at. Okay, let's take a simple data set here of the ages and heights of a set of people. Okay, so this is our data, and of course the mean age is 11.39, the mean height is 61.31. Now one thing you could do is to represent this entire data set simply by the mean of the age and mean of the height, right? So rather than deal with the 12 separate cases, you can say, well, as far as I'm concerned, this is what describes the data. I don't care about the differences that exist between the individuals. I'm going to treat it as, you know, a group whose mean age is this and whose mean height is that. Okay, so here you're doing a one-size-fits-all approach. It's a fantastic reduction in complexity from 12 all the way down to 1, right? Instead of dealing with 12 different people, you deal with all of them as if they're of the same type. Okay, so there's a factor of 12 reduction in complexity, but of course there is no variety retention at all. Okay, because there is variety here. There is variety in age, there is variety in height. We're not retaining any of that. We're saying I'm going to treat all of them as this age and all of them as that height. Okay, so that's the problem. There is no variety retention. Variety retention happens to be 0. Okay, let's go to the other side and say I want to retain all the variety. Then that means I can put each case in its own cluster. Treat each case as separate, which means I end up with 12 clusters, perfect variety retention, because all the variety exists because there are 12 different clusters. I'm treating every person as separate. Okay, but of course complexity reduction is 0, right? Because you had 12 cases, you now have the same 12 cases. You have not reduced complexity by any amount at all. Now at this point, it might be a good idea for us to take a look at cluster analysis versus classification, because cluster analysis sort of looks like classification. You're taking the cases, you're putting them into one of a few clusters, right? So that looks like classification. But the key difference is when you talk about classification, the objective classification already exists, right? Because in your data set, people are identified by the class to which they belong. Whereas in cluster analysis, the classification doesn't exist, right? You're trying to determine that classification based on your data. Okay, that's a big difference between the two. You shouldn't get confused between these two things, right? In cluster analysis, there is no objective definition of classes. We are trying to subjectively identify the classes based on cluster analysis.